water auditing. I can't think of anything more boring. And here we have a webinar on water auditing. The good news is this is not boring. I know, a water audit, what do? You count toilets, you count sinks, maybe you measure flow rates, and oh boy, that is really dull. But what's really cool is there's a lot more involved in watering or water audits, or there could be if you knew more. That's why we have this webinar, because once you listen to the webinar, you'll realize there's a lot more opportunities than you thought there were. Take a listen. I think you're going to like it.
Hi everyone, this is Christian Orsi with Abraxas Energy. Here to present a water presentation, some opportunities for you to look for. Some background, I took the first CWEP class and passed it probably 4 years ago now. So this is just kind of bringing in my knowledge from that class in so everyone can share the knowledge, because water is going to be a very important factor going forward. And when you evaluate energy, you also have to evaluate water as well. So let's start off why you should focus on water. Water, clean, fresh drinking water is a finite resource that we really need to conserve right now. Colorado, I live in Colorado. We were just stricken with a drought for 2 years, and then we got some awesome snowpack this year. So we're almost out of drought conditions, but still important to save water where we can as the city expands. And water resources go to different industrial processes as well as residential uses and things like that. I guess one of the most important things to take away is most people don't know how much water they actually consume. I've talked with many facilities and they just say, oh, we just pay the water bill. We pay the water bill. We don't really track our water use. We don't track the water use on our cooling tower, which is a very important thing to track if you're trying to actually optimize water usage at your facility. Next slide. So I guess where can we save? Anywhere water is used, really. Restrooms, kitchens, any type of cooling equipment that uses water, be it a cooling tower or a once-through cooling loop. Laundry especially. Central laundry facilities at campuses are a huge opportunity for water savings. And then we go into other things like landscape, labs and medical equipment. There are some specialized pieces of equipment there that you might not look at as using water, but they do consume large amounts of water, or can consume large amounts of water. And then pools, of course, you get evaporation from the pool surface as well as splash out from the pool, filtration systems and things like that. Next slide. So this is just, end uses of water at various facilities. I think I took this from the WaterSense website. So as you can see, domestic water use usually makes up about 30% or more. And then just depending on your facility type, you have different areas of intensity. So the US decided to standardize some water fixtures in EPACT 1992. So they set forth a maximum allowable flush of 1.6 for commercial toilets, urinals, 1 gallon per flush, 2.2 on commercial faucets, and 2.5 on shower heads. Since 1992, we've come a long ways. We've made things a lot more efficient. WaterSense and Energy Star actually recommend some lower flow fixtures in the commercial and residential, or the commercial cases. And then, of course, there have been more reductions. So we can, for a standard residential toilet, you can go down to 1.28 gallons per flush. It's pretty safe for almost any application. You can go down to a 1.1 with a pressure assist vessel. That's pretty safe in most applications as well. You can go down to even an ultra high efficiency toilet, a 0.8 gallon per flush, but you do need to be aware that there are some limitations there. There are some issues with high-rise applications or areas where the water isn't able to push the waste all the way through the system to the central line, and there can be clogs in those sort of situations. So you just kind of have to have your plumber evaluate the piping to make sure your 0.8 gallon per flush toilet could work. Next slide. So yeah, when you're looking at a toilet, usually on a residential type toilet, they have the flow printed right on the toilet. For commercial fixtures, it's a little more difficult. Sometimes they have it printed on the china, but you can't really trust the china. Really, on a commercial fixture, you're looking at the flush valve, and that flush valve has either a diaphragm in it that's rated at 1.1, 1.6, or maybe 3.5 gallons per flush, or a piston type valve. And you won't really be able to figure out what is in there unless you have some extra stock from your facility staff and they say, oh yeah, this is the diaphragm I put in. So this is one opportunity. If you have a commercial fixture, you could install this uppercut flushometer where you flush up for liquid waste, and I think it's only a gallon per flush or so, or 1.1 gallons per flush, and then you flush down for solid waste, gives you the full 1.6 gallons per flush.
Hey, Christian.
Yep.
Weren't you involved in measuring the flow in toilets? Because sometimes, you see them and you really don't have a clue of what the flow is. Did you do that?
Yeah, so I guess
What'd you guys do?
a quick rundown. So if you really need to do like M&B on a toilet, you need to know how much that toilet flushes, because it could be anywhere between 1.6 and 5 gallons per flush, but you don't know. So what you do here is first you evacuate the bowl of all water, stopper up your bowl, flush the toilet once, and evacuate the water from there into a measuring bucket. So you're effectively taking all the water that toilet is flushed into the bowl, into your measuring container, measure it out, unstopper the toilet, put the water back in, and you should get somewhere between 1.6 and 5 gallons most likely. Another, I guess, quicker way to do it, if you're just trying to estimate very quickly, you can count the number of seconds that a commercial fixture flushes and divide that by 2, and that will give you a general sense of the GPM that fixture is flushing. So for a 1.6 gallon per flush toilet, you'd expect it to take a flush time between 3 and 4 seconds. That's just kind of a general rule of thumb, kind of loose, but it can get you a quick estimation.
Thanks. That was good.
Urinals, I usually recommend 1.25 gallon per flush fixtures. The waterless urinals, while they're great, if you maintain them, you keep up with the O&M practices. If you don't, like most facilities do, you start to get stinks, you start to get clogs, and people just become a complaint, and they end up taking them out or installing, higher flow urinals right next to them. So waterless urinals, again, here's what a urinal looks like if you do not take care of the piping. It starts to get a buildup of all that blue sludge, and then the toilet stops flushing, and you get a nice, urine smell wafting out of your drain. So just make sure if you do recommend a urinal or waterless urinal, you recommend O&M as well. Don't just claim water savings. You're going to have to claim water savings minus your O&M practices to take care of this urinal. Faucets, we generally recommend going down to 0.5 on any restroom faucets or things like that. There has been some pushback and discussion in the water community. 0.8 GPM aerators seem to be more reasonable. Fewer people disable them. Of course, you could just recommend vandal-proof aerators, and they'll stay on there unless someone has the tool to take them off. But if you're going to go low flow, recommend the vandal-proof, unless you want to end up going through and inventorying all your aerators, relatively often. Shower heads, you can go down to 1.25 GPM. I wouldn't recommend it. I tried it. I didn't much enjoy it. I have a 1.5 GPM shower head installed in my place, and it works just fine. I guess one thing you have to be aware of when you specify low flow fixtures is the hardness of your water. You don't want to recommend a low flow fixture only to have it clogged up because there's no proper filtration at your site. If you have a water softener, you can recommend the shower head on the left. That would probably work. But if there's no water softening system, you really want a single orifice, and that way the bigger particles will pass through, like the bigger particles of calcium or things like that will pass through and not build up and clog your orifice, and you'll still get full spray. So commercial kitchens, jumping in there, a lot of opportunity. Some things you might overlook. Pre-rinse spray valves, of course, which you use at the kitchen station to wash off the dishes before you put them into the dishwasher or the flight machine. Ice machines, garbage disposals are one that are often overlooked. Tray wash stations aren't very common. Dipper wells, kind of like when they have in the ice cream shops to wash their scoops. Those usually have continuous flow. Convection steamers and dishwashers. So next slide. Pre-rinse spray valves. So you want to see something that looks similar to the pre-rinse spray valve on the left. You can go down to 0.767 GPM is probably the ideal range if you have an optimized spray pattern that's going to, fan out and clean the dish in one pass rather than having to use that big 4.5 GPM to blast food stuff off your plate. Always measure these. Usually the nameplate is printed on the front of it, so you might have to turn it around at you to look at it. Just don't spray yourself in the face. I've done that. Ice machines are another good opportunity. Always, always, always check the connections going into your ice machine. If it's water cooled, it's almost guaranteed to be once through water cooled, and that's a huge opportunity for savings. They usually have a constant flow, maybe 2 or 3 GPM going through them to provide cooling for the compressor. Instead, you can connect that to a chilled water loop or condenser water loop and provide cooling that way, so we're not having to waste the once through cooling. We're just using chiller energy or another source of energy to cool. And you can also install these cool little counterflow heat exchangers, so when you have ice in the machine, it's continuously melting, so that's always going down the drain as about 32-degree water. So you can install this little heat exchanger to pre-cool the incoming water and effectively save a little bit of energy. Garbage disposals. So the important thing to look for here is there is a constant flow required by your garbage disposal. Usually it's between, I would say the ones I've seen have been between 5 and 9 GPM. So to make up that 5 and 9 GPM, you have a combination of basin nozzles and a dedicated supply that goes directly into where the garbage disposal blades are. What you want to check here is do the sum of the basin nozzles and the dedicated supply, is that equal to just the bare minimum of what that garbage disposal requires? Most times you'll have a plumber come in and they'll just install a dedicated supply of, a half-inch pipe. Well, a half-inch pipe gives you a lot more flow than 9 GPM plus the basin nozzles. So what you can do there is either install a flow restrictor on that dedicated supply, and also make sure that you have a solenoid valve on that dedicated supply. I've seen one supply where the plumber didn't install this solenoid valve, so they just had a constant flow of almost 9 GPM going through this garbage disposal, all 8760. So that was a large water savings opportunity there, just from a quick inspection of a garbage disposal. So yeah, this is just telling you dedicated supply plus basin nozzles. Just make sure that's equal to the minimum of the disposal. Tray machine or tray wash stations, I haven't seen too many of these. Things you can look for, just low flow nozzles. Make sure that they're optimized, pressurized nozzles, not and they're clean as well. You don't want scaled up nozzles, or else you won't get an optimized spray pattern, and you'll waste some water. Dipper wells, just those little things that they have at the ice cream shops. They might have them throughout commercial kitchens. Usually here you can just install either a solenoid valve on a timer that will shut off, when the ice cream shop is closed, so that that's not continuously running, or you can install a flow restrictor, restrict that down to whatever flow you deem minimum to effectively clean the equipment and provide the cleaning. Convection steamers come in 3 flavors. So one convection steamer will receive steam from a remote boiler. These are probably the worst, the most lossy, I should say, because running this piece of equipment, you need this piece of equipment all year. You can't just shut down your steam boiler that's also serving your hot water, your space heating. You can't shut down that boiler just because you have this convection steamer on it. So you're running a very low load on that boiler, most likely in the summer, wasting large amounts of energy there, as well as water through that system, because you're probably not returning a ton of condensate back to your boiler. Another system is the boiler based. It has an internal steam generator. You just connect a water supply to it, and it will generate the steam. Steam flashes into your cooking area, heats your food, and then will go down to your storm drain rather. And a connectionless is entirely enclosed. So you only connect it to electricity, and then you put in a basin of water, and it uses this basin of water, heats it up to steam it, puts it through, cooks your food, and then it returns that water, that condensed water, back to the tray, and it reuses that water. So you're always reusing this warm steam rather than having to heat cooler water and fresh water every time. So yeah, I usually recommend connectionless steamers. I've seen paybacks. I think one of the commercial kitchens I had, it was under a 5-year payback, but they were continuously using the convection steamers. I would say a typical payback is probably 15 years or so. It is a good item to replace if you are looking for water savings. If your client's really adamant on water savings, this is a good place to look. So again, this is just the energy efficiency, comparing different technologies here. You see the connectionless is the most efficient just because you're reusing that hot water, that steam, that already 200-degree water, only having to add in maybe a gallon per day to make up for water that's evaporated or comes out in the food. And here's a comparison of just the energy consumption of different connectionless steamers rather. Connectionless at the bottom uses half the energy that the other ones do. Moving on to dish machines, there are 4 different types. They're under counter, door type, rack, and flight. Most of the time in a commercial kitchen, you'll see the door type and the rack. You might see a flight machine if it's a very big commercial kitchen. What can you do with the dish machines? Not much can be done with the first 2. You can upgrade them to Energy Star. That's really about it. For rack and flight machines, there are a few more things you can do. Usually, if it's not an Energy Star rated machine, full replacement might pay back, just depending on how often that kitchen is used. Another thing you can do is just reconfigure the water supply so that it's a counterflow water supply, so that you're always using the cleanest water at the final rinse, and then you move that water through the next basin, provide the second rinse, and then you move that water, that very dirty water now, to provide the first rinse and take off the bulk of the grime and such from the flatware and plates. You can also install high efficiency nozzles. Again, just look for any nozzles that look to have been damaged, through plates or things going through the dishwasher. Maybe the nozzle is no longer in place and it's just a stream of water coming out of it. Easy place for energy savings then. High efficiency pumps and motors. I haven't seen this really pay back, but it's something you could look for if you have a high enough usage on your dishwashers. And heat recovery. Almost every dishwasher has a booster heater to heat the water from usually 140 coming into your commercial kitchen up to 180 to provide that final rinse for your dishwasher. So using a heat reclaimer to preheat, go from air to water, preheat that incoming water can save you some energy. In some cases, a lot of energy, but I think I've estimated mine more at 50%. Rather than 80. Moving into laundry, residential and light commercial, you won't really find much to do. You can replace, both washers with Energy Star rated equipment. I think dryers are Energy Star rated now, but they won't really save unless they have a moisture sensor, because you're going to still need the same amount of energy to dry your clothes, with either a new or an old washer. So the moisture sensor becomes the key component here. With commercial machines, you have extractors, which are on the top, and tunnel washers that provide continuous laundry. I have never seen a tunnel washer. I've seen large extractors with both of those systems, the most crucial thing becomes finding a system that can reuse your rinse water. You don't want to continuously pump new water into your laundry system if it's almost a continuous use. So here we can use, if you have, a hospital where you need reverse osmosis water for procedures, for humidifiers or things like that, you can use the reject for your laundry. You have to, treat it a little bit, soften it, but overall you can use that. It becomes an effective source if you have large amounts of laundry being done. And then, of course, you can install a final rinse water recovery system. So you're just basically reusing the wash water at 120 degrees, just filtering everything out that you've washed out of your clothes, and then running it back through your washer at 118 degrees seems a little high. I've seen 100 degrees, but that's energy savings over having to heat your water back up from groundwater temperature of, I don't know, let's say 60 degrees up to 100, and then plus you're getting to reuse the water there, so you're not wasting more water. Another thing that's possible that makes sense in hotel applications, prisons and things like that is in an ozone system. I've heard claims up to 60%. It is how long it can extend the life of linens, and 60% to a hotel. If you extend the life of all those bed sheets, towels, things like that, that's a large chunk of change that you could claim as O&M savings. The other thing that you can be claiming is the water is not required to be up to 140 and 50 to activate the detergents. So you can run it with 90-degree water, save yourself some domestic hot water heating energy there as well. I've heard claims that it does reduce drying time and chemical use, but I don't personally have experience with it, but this came directly from the CWEP class. But yeah, one thing you should be aware of is ozone does off gas slightly, so you can't put it in an enclosed space like a basement or something like that unless you provide sufficient ventilation. Make sure you have an exhaust shaft or duct over the unit so that you're sucking out the ozone, and make sure you have an ozone sensor in the space as well, so that an alarm will go off letting staff know they shouldn't enter. Although when your eyes are burning and you should know to leave the space. So here's just a comparison of all the different components that you can save. I'm not sure where I took this from now. This was a few years ago. I think this was from one of the manufacturers of the ozone system, but they're essentially claiming the system saves a lot. So it does cost a lot to install as well, so you do have to be aware of that. I researched it briefly, but I haven't recommended it anywhere, so I don't have a gauge on payback for a system like this. Irrigation, the things you do not want to see are obviously what you see in the field here. Broken heads, broken sprinkler systems. Maybe this is just a broken pipe underground. And you also do not want to see just a timer in control of your irrigation system, just because that timer isn't smart enough to shut the system off when it's raining outside, when you don't need the sprinklers running. I'm sure you've driven by schools or things like that where you've seen the irrigation system running even though it's been raining for a week.
I read a study recently, or maybe it was about 5 or 6 years ago, and it said that the most efficient way of doing irrigation is with people. And as soon as they put in these automatic irrigation systems, then we started wasting lots and lots of energy, because people are smart enough to realize, oh, it's going to rain tomorrow. I'm not going to irrigate. And people aren't going to spray water onto the sidewalks and like irrigation systems do. And it's as soon as we put in these irrigation systems, that's when all the waste started happening.
Right. But sometimes you can't afford to have a dedicated person to water your, acres and acres of fields.
Absolutely.
So the next best thing you can do is upgrade yourself to a weather-based smart controller. So that you can either have one that has a weather station attached to it and it will take in current weather conditions, or you can have a different weather station or different system where it communicates to, I think, a weather station like an airport or something like that to predict weather conditions or to take weather conditions from there if you have wireless connectivity. Another flavor would be called an evapotranspiration meter. And what is that? Evapotranspiration just means how much water is evaporating from your vegetation. So what that's going to do is it's going to measure how much, or measure and calculate how much water is evaporating from your vegetation, and then only activate your sprinklers to spread out as much water and replenish that water. So you're not going to overwater in theory. Another thing you could do, retrofit your sprayers. You shouldn't have any of these fine mist sprayers anymore. Their efficiency is horrendous. Almost all water utilities, or maybe Denver's a little different, they offer very good water rebates, or they used to. They give rebates out for the single stream rotor heads. And this application here, this stream rotor, that's what we want to see. That's going to distribute water around and deliver it more directly to your grass, whereas the fine mist sprayers, more of that evaporates before it even hits the dirt. It'll evaporate on your grass. So it's just not a good deal. I guess another thing I didn't cover is, when do you water? Do not water during the day. You'll end up sunburning your grass, and then you also waste a large amount of water. The most ideal time to water, I think, is in the early mornings, or even at night after the sun sets. Just make sure you don't water when the sun is out, or else you're going to end up wasting some water due to evaporation. Other things you could do with the distribution system: subsurface irrigation is best, but it's expensive. Just be aware of that. High efficiency pumps, if you have a large irrigation system on VFDs. Install flow meters so you can identify if an irrigation zone has a leak. It'll register a flow when your irrigation meter is shut off. So that should be a red flag to you that there's a leak in that branch of the irrigation system, so you can go investigate that and figure out where your leak is, rather than letting that leak go unnoticed for a year or two, or who knows how long that could go unnoticed. Pools, things that affect water use, of course: the pool size, evaporation rate, if it's an indoor pool, if it's an outdoor pool, do they heat the pool? If they heat the pool up to 90 degrees, or some warmer temperature, of course you're going to get more evaporation coming off the surface of that pool. Leaks, pH, and the chemical content of the pool is also a big factor on how much water they add to the pool. Sometimes they screw up on the chemicals, and they have to drain some of the pool water and add more fresh water. So it's just something to be aware of. Evaporation, what can we do there? We can install physical pool cover. I usually don't recommend these, just because they never stay in place. Or every site I've gone to, oh yeah, we used to have a physical cover. It's over there in the shed, and we haven't used it for 2 years because either it broke, or it's just a pain to put out, or something like that. So I usually don't recommend a physical cover. Automatic covers, maybe if you can guarantee that it won't break, or you have a service contract in place. But most of the times those are disabled too once they do break, because the site doesn't want to bring out a service person to come service that. They just figure, oh, let's just leave the pool uncovered. So instead, you can recommend a liquid pool cover system. This really only works if you have a set schedule on your pool, because once this alcohol formula is pumped into your pool, it goes up to the surface. The alcohol evaporates and leaves the chemical coating the top of the pool. So once you disturb that surface, you disturb that coating, it disperses. It won't reform. So you just have to make sure you have a set schedule on your pool, so that no one's going to be in there to disturb the surface when you pump the chemical in. It has been tested. It's safe for human consumption. Well, not direct consumption, but for humans to be in, and it's also biodegradable. But it is something that you have to pump into the pool daily, and it does evaporate. So it's just an added on.
Have you seen one of those, Christian? You ever seen one of those anywhere? I
have not, but I've talked to a few people who have.
And what have they said?
They said it's in place. That they had issues acquiring the chemical at some point. I'm not sure if it was this Heat Saver brand. I think they used a different brand, but other than that, they said it works. I don't know if they did any M&V on it.
Okay.
But pool filtration, this is just something to look at. They should have sand filters and things like that. Just make sure that they aren't continuously backwashing those sand filters. Sometimes they do, and it's a continuous flow coming out of the filter. You might have a drain in the same room as the filter, so just look at the drain. If there's water coming out, there's something wrong with their filtration system. And the other thing you can do is figure out what your turnover rate for your pool is existing if it's a constant speed pumping scenario, and you can reduce the speed of the pump to meet the required turnover for your pool. So I think it's six to 12 cycles cycles per day when it's occupied, and then 2 when it's unoccupied. So that can be something you investigate. Backwashing, I guess this is what I just went over. Just make sure you have something that controls the backwash across your filters. Again, an ozone system you could install it in the pool so you can eliminate chlorine use. If that's a concern to your pool, if people have redness in the eyes or things like that, or if chlorine's just expensive at your site, this might be an alternative thing. You can install an ozone generator system to provide sanitation of the water rather than a brine or a chlorine. HVAC systems, 2 major users of water: cooling towers and boilers, steam boilers. So in your cooling tower, you have six places your water goes. 3 primary are your evaporation losses, drift losses, and blowdown. And the other ones that are minimal or should be minimal are wind losses, overflow, and leaks. Really, overflow and leaks shouldn't be present in a well-maintained tower. So what losses can't we deal with? Evaporation, of course. Water has to evaporate to remove the energy. Drift is always present, and wind, you can't control the wind, but you can put wind screens on your cooling tower to mitigate wind losses if you are in a very windy climate. What other losses can we mitigate though? Blowdown, overflow, and leaks. Blowdown especially. Leaks and we can go through and we should seal all leaks. And then overflow we can deal with by fixing the float arm, making sure that float arm shuts the valve the makeup water valve that's coming into the tower when the water level rises high enough in the tower. Those 2 things are simple solutions. Blowdown, however, it's a bit more complex. Usually it's based on your conductivity in your tower. You try to maintain a ratio of dissolved solids in your blowdown inside your tower to a ratio of dissolved solids inside your makeup water. Usually you want to see somewhere 6 is pretty standard. The data center I was just at went up to 10 to 12 cycles of concentration, and 80% of their water is used in the cooling tower, and I'm supposed to find 20% water savings. So that's a fun exercise. So how do we increase the cycles of concentration without impacting our cooling tower? Really, it comes down to filtration and water treatment. If you really want to increase cycles of concentration and where you have hard water, install a water softener. Just a water softener alone can probably get you up to 8 cycles of concentration, in addition to your typical water treatment, of course. But what else can we do to increase our cycles of concentration? You can also utilize different sources of water. If we use a source of water that we were going to pipe down the drain anyway, like AHU condensate, if we were to recover that, our RO reject water, any sort of alternative water source that's relatively clean, not gray water necessarily. I don't think you can use hand washing water, but these other sources of water should be able to be used as long as you pre-treat it. Make sure you're not pumping in water that's very salty or something like that, or has a high mineral content. You just have to check that you treat the water correctly. And then, of course, blowdown should be based on conductivity. There are sites that either have continuous blowdown, means they always bleed off, like 3 GPM from the tower, no matter what, all hours. So that's terrible. That's a terrible practice, because your conductivity could range from, your cycles of concentration could range from, 2 up to 10, just depending on how often that cooling tower is used. And then you shouldn't ever have it based on a timer as well, because again, that's not addressing what the situation is in your cooling tower right now, what your conductivity is in the tower right now, but rather what's your average, worst case scenario, I believe is what they usually put the timer for on a peak day. If we're running the cooling tower continuously, we need 15 minutes of blowdown. Okay, but what do you need in the winter? Probably only, 30 seconds, a minute. So that's another source of water that could be saved. Boilers, kind of the same thing. Blowdown should be based on conductivity. Make sure there's no continuous blowdown. Condensate return meters, actually that's another good one with the cooling tower. You should always meter your cooling tower makeup water and blowdown. That is the most accurate way to really determine your cycles of concentration. You can't improve what you don't measure. So if you're actually measuring what your blowdown is, what your makeup water coming into your tower is, you can calculate your cycles of concentration more effectively than you can when you're just measuring conductivity. And this is something I saw when I was taking conductivity readings at that cooling tower that was running 10 cycles. I calculated from 6 to 12 cycles of concentration, and that's just because my meter wasn't very accurate, or I'm not sure, maybe just fluctuations in their water. I got very different readings, so I didn't really trust that. I trusted my meter readings and the cycles of concentration that way. Condensate coming back to your boilers is a lot more important though, because this contains not only water used in your steam, but also the energy used in the steam to generate the steam. So you can use this water instead of cold makeup water, and then your boiler will do less work, and then you're of course saving water because you're not introducing that additional water to your boiler. And that comes along with steam trap maintenance. If you have a steam trap that is just either blowing through, plugged up, or maybe leaking, that's a source of wasted water right there. If it's a source of wasted steam, it's a source of wasted water as well. Hospitals, they have some equipment that you can optimize. Sterilizers, liquid ring pumps, I don't really see those too often. Reverse osmosis and x-ray machines. So sterilizers, really just make sure that they shut them off when they are done using them. They usually put them into a standby mode. If it's a clinic, and they're only open from 8 a.m. till 6 p.m., then they have no procedures after that. You should probably recommend they shut down their sterilizers after that, because then they're just maintaining an occupied temperature, a ready temperature, even though there's no one that's going to put a load through the sterilizer. Another thing is usually they'll temper the water coming out of the sterilizer, because you have to temper it down to 140 degrees generally before putting it through the storm drain. So they put a continuous supply hooked into the discharge from your sterilizer to make sure that it's always below 140. But when your sterilizer isn't running, that continuous supply is still pumping, up to 6 GPM just down the storm drain. So you just need to make sure there's either a solenoid valve there, or more ideally, you install this water miser tank that effectively just stores the discharge water in a tank, and it radiates the heat to the room. And then if the water level rises too high and it needs to discharge to the storm drain, it'll temper it back down with the domestic cold water just through this sensor right here. Once that goes up above 140, this valve opens and this chamber will be tempered down to 140 and then there's supposed to be a solenoid valve here as well. And then this valve would open and discharge. Sterilizers or vacuum units, I haven't seen these too often as far as things you can optimize. Most sterilizers I've seen have been new, and there haven't been much opportunity there, but they do make systems that you can install to optimize your sterilizer if it uses an ejector system. Reverse osmosis water, usually most hospitals have it. Just make sure you measure and figure out what the ratio is of RO water to wastewater that's coming out of their RO system. Just because if you pass the water through an RO system once, you're usually only taking maybe 20% of the water you pass in, just depending on how much you filter out. 20 to 50% is what you're getting out as usable RO water, purified water, and then the rest you're sending down the drain as a concentrate stream. So to improve that, you can just filter that concentrate stream again, send it back through your RO system. The consequence there is, of course, you're going to go through your RO membranes a little more quickly. Just depending on the cost of those, you can weigh and see if it would be more efficient to save the water, or if it's better to just save on the membranes. And of course, you can send the concentrate somewhere else, use it for an alternative water source, but you do have to filter it and treat it before you send it into a mechanical piece of equipment like a boiler or a cooling tower, especially. Liquid ring pumps, I haven't seen many of these. They use water to maintain the seal around the impeller. So what you can do here is just replace it with a dry pump, and you'll reduce the power consumption and eliminate all your water consumption with that pump. Or you can install a water or retrofit kit on the pump. X-ray machines, if there is an old machine or a film machine, they might be once through cooled with water. So that's just something to ask for in the imaging department. Make sure they have all digital equipment. Generally, if it's digital, it's, cooled by a remote condenser or radiator or something like that. And that's about that.
I got a question. So
Yep.
I've seen a lot of ESCO projects, and they seem to, on a lot of the performance contracts, they seem to only focus on faucets, toilets, and urinals, and maybe a little irrigation, but they don't really touch any of that other stuff. Why? Is it because all those other ones are there's just not good payback there, or what? Why?
I would say sometimes with the commercial kitchen, especially, it's just things they gloss over, like the pre-rinse spray valves. It's one or two valves out of,
Yeah.
and that's
So
what,
it's not a lot of
$500 out of a,
savings. Yeah, it's
yeah,
nothing.
yeah.
Right.
So most of the stuff is smaller stuff that you can offer on an energy audit or a water audit, but you might not be able to offer as an ESCO package, or you might not look at it with an ESCO package. Yeah.
Well, I mean, but ESCOs are often looking for anything they can, any savings they can, so they can pay for the big chiller or boiler retrofit or controls retrofit. So yeah, but it's like, for example, the once through water for the ice cream scoops or whatever. I mean, that one's so obvious. Or the water machine or the ice machines that have the water running through just once. Those are obvious winners, I would think. And I just don't know why we don't see more of that in ESCO projects.
Well, I haven't seen, I've seen only one once through ice machine, and that was connected to a condenser water loop already.
I've seen them. I'm trying to remember where I
Yeah.
saw one. The only time I actually even looked for it and I saw it. Oh, it was at a hotel. It was at the Hyatt in DFW. Yeah, hotel I did it. I think it's really common actually in restaurants and hotels. We did have a question. I think there's only one, and it's kind of general, and it's about M&V options. It's just saying, well, what M&V options would you prefer for water savings? Well, I think I think it really depends on which M&V maybe it's all the same. Maybe all the different retrofits you do the same on, but you tell them rather than me tell them. What have you seen on ESCO projects for M&V for water?
The best way to do, like, just if you're going to do domestic fixtures like urinals, toilets, things like that, is to install an inline flow meter on the toilet or the urinal. That's the ideal way to do it. Or you can go around and do the other method where you plug up the drain, suck all the water out, measure the water, and that would be your baseline for that fixture.
I think the second one's more likely, but I think even what I've seen is I don't even think they do that. Maybe I'm wrong, but I think they often will just say, look, we all agree the manufacturer says it's using this many gallons per flush. I think we can believe that. And on average, we read on the China, it's saying that they're using this many gallons per flush. We can believe that. And I think that's generally how it's done. They just use an option B or option A, just measure a lot of stuff and then estimate the number of flushes and go from there. That's my guess how most of this is done. Yeah, but generally, when it comes to doing irrigation, though, doing M&V on that, I think then you really do need a meter. Because I guess you could guesstimate and say, well, they were doing it this many hours. No, because then you need to know the flow rate. How much flow is going through all those nozzles. So you really do need a meter. If you're
and that comes down to, with irrigation, you'd have to do a catch cup study, really, if you wanted to get into it, because you need to figure out what your existing system's baseline is. So the only way to do that, you can't just take the rated flow of your sprinklers. So you have to set out catch cups, space them out every 3 feet or so in a square pattern, and then let your irrigation system run, see how much water is actually distributed, across your entire lawn, and then you figure out how much water actually came out of it, and how efficient. That helps you figure out how efficient your existing system is, though.
Oh, you're measuring that versus what was what the meter said, because some of it gets
Yeah.
evaporated away. Okay,
Yeah.
got it. And some of it ends up on the sidewalk. Okay, so here's one. Other than a meter on a makeup water line, what other ways are there to calculate water savings in pools? Boy,
So for that, let me
I would think
see.
that's the way to go. It's the meter.
That is the way to go. Alternatively, you could do a calculation just based on, the temperature of the water, and you can calculate how much water is evaporating, do a bin sim if it's an outdoor pool, figure out how much water evaporates at each hour.
There's
Based
tools.
on,
I'm sure there's online tools actually even for
well,
water.
so the tool I used to use was it's Windows 97 based or 98 based, I
Is that
think.
Market Manager?
No, it's God,
No.
I'll have to look. I can't remember it now
Market
because
Manager.
my computer can't even run it.
Some of these folks remember Market Manager, and Market Manager had a really good pool model, and that's what I use. I have an XP computer that runs Market Manager. I just turn that on when I need to. Yeah, I don't know how folks do this. I
I think
just use models.
there's also been studies. I think the EPA or maybe as NREL, they released a study maybe in the 80s that gave evaporation rates for different bodies of water in different states, and that's kind of how I based some of our calculations on. Just figured out what's the closest body of water. Okay, in April it says it evaporates a total of 12 inches. Okay, but then you have to figure out that's a body of water that's maybe at 50 degrees. My pool is at 80 degrees. It doesn't really line up
It's
too well.
better just to use the Market Manager model, man, because
Yeah,
that deals with the local weather. You put the weather in there, and it can do indoor or outdoor pools, and it can handle all that stuff. And I think there's other models too out there. I'm sure there's an online one somewhere. Okay, I think that's it. We only have 2 minutes left. Hey, Tyler, what do you got? We only had 2 questions, so
I think that was it. But everybody knows the email on the screen. If you have additional questions, send it to that email, and I'll forward it on to Christian, and he can reply back to you if it's something more technical. Thank you again, Christian, for a super in-depth webinar. It was a lot of great information that everybody enjoyed. We'll see you guys in June, and thanks for joining us.